Hey guys, James coming back in with another video. In this video, I'm going to go over a few different geometrical math problems that involve quadratic equations. So in this problem, it says you have 600 meters of fencing in a large field. You want to make a rectangular enclosure split into two equal lots. What dimensions would yield an enclosure with the largest area? Okay, so this is the enclosure. You want to have two different lots, okay, but you want to have the width and the length be such that they yield the largest enclosure, right? And you only have 600 meters of fencing. So how are we going to do this? How are we going to make an enclosure with two different lots that will yield the largest enclosing? Okay, it's an interesting question, very interesting question. To start, I'm going to copy this down, but specifically before I do that, I want to talk about what you should really be looking for when you're looking at something like this. Okay, so we have, as far as widths go of this enclosure, 1, 2, 3 different widths, and we have two lengths, right? Because obviously this is the length. These are different widths because we're going to have two enclosures. We're going to have a fence in the middle as well. Okay, so to start with problems like these, you really just want to write down your different lengths and widths. Okay, so if you have 3 widths, it's going to be 3W. If you have 2 lengths, it's going to be 2L. And you're going to set everything equal to the amount of fencing that you have, okay? So in this case, 2L, it's going to be 2L. So let me just write that down. 2L plus 3W equals 600 meters of fencing, okay? Again, we have our 3 widths being represented as the 3 widths here, 2 lengths being represented as the 2 lengths here. In order to find the dimensions of this, what we're going to do is, first off, we're going to have an algebraic expression representing one of two things. We have the length and the width. They're going to add up to 600 meters of fencing. We want to solve for one of those two. So we could solve for the width, we could solve for the length, and when I say solve, what I really mean is I'm going to, whatever value I'm going to solve for, like say if I'm going to solve for the length, for example, I'm going to take the length, right, to solve for the length. I'm going to say 2L, and then I'm going to say equals, right? I'm going to say equals. I'm going to bring this over to that side of the equation, which is going to make it a negative 3W plus 600, right? And then again, just, you know, your normal solving techniques, which everyone should know. That's not what I'm going to be getting into these videos. But in solving this, we're going to divide each side by 2, right? So we're going to solve for the L, and technically, you know, I mean, this is solving it, right? We have L by itself. L equals, we have negative 3 divided by 2. Negative 1.5W plus 300. And that's what we want, that's what we need to start out with. Like I said, you're going to take your widths or lengths, add them up into an expression like so, and you're going to solve for one of these two. And in doing that, you're really just going to rearrange it so that you're going to have, you know, 3W equals, you know, the rest of the values, or in this case, 2W equals the rest of the values. And in doing that, we had positive 3 turned to a negative 3 when we took it over to the other side of the parentheses. And that's really the only thing that we changed here. We moved this on this side of the parentheses, and so the parentheses was now placed in front of the 2L, right, by default, once we move this out of the way and put it over here. So that's where this comes from. 2L, right, equals negative 3W plus 600. We went ahead and solved for the L by dividing by 2, right? Divided everything in here by 2, and we have L equals negative 1.5W plus 300. Now, when we have an algebraic expression, obviously this does not exactly give us the actual length, right, of L. It does not give us that in meters, but it's an expression that L represents, because L is by itself. Okay, we have unknowns here, obviously. But we're going to take this, and we're going to come over here, and we're just going to write this. Area is equal to width times length. Right, and that's beyond the scope of this video, and you know, I'm not teaching how to find area. Everyone who watches this video should know that. But, you know, really, you're just going to have, you know, I mean, I think everyone knows this, you know, length times width, times those together, you're going to get the area of the rectangle. But in having this, what we want to know is that if we have area equals width times length, or length times width, and we have an expression here that is representing the width, what we want to do is just go ahead and plug this. We have an expression here that's representing the length. We just want to plug this expression into this value. Okay, pretty simple. Pretty simple. If you watch this video, you should. I think anyone who really just it takes a little bit of time just to watch these, is really going to understand this quite well. Okay, so we're going to have area, okay, is equal to W times length, which in this case, we're going to write the expression of length. And from here, to find the area, I'm really just going to take this and multiply it across. So we're going to have area equals negative 1.5 W squared plus 300 W. And this right here is a quadratic equation. From here, if we want to find out the length of the width, which is what is being represented right here. If we want to find out the length of the width here, we can go ahead and do what we would normally do for quadratic equations in finding the axis of symmetry. And the formula for finding the axis of symmetry is negative b over 2 times a. Okay, so again, we have our a, b, and technically right here, it's plus 0. It's just not being written in our c values right here. Right, so we're going to take this value. It's going to be the opposite of whatever the sign is here. So again, it's going to be negative 300. Right, negative 300 over 2 times, and what is this? Negative 1.5. The a value is negative 1.5. And then just go ahead and calculate that out. 2 times negative 1.5 is negative 3. This is really negative 300 over negative 3, which really is just 100. Okay? So this is the width. This is what W is. That's what the W's are representing here. It's 100. So if we plug the 100 back into these W's, it's going to actually give us the area. Okay? What you could also do to find the area is take this 100 and plug it into the length expression. And since I said what you have here is the width, you also have the length. And we know that area is equal to width times length. So if you plug this 100, which is the width, in here, and then calculate that out, you're going to come out with an actual number of the length. And we already have our width. And we can just multiply those together to get our entire area. Or we could plug the 100 back in here for the area equals expression and get our area that way. So let's do it both ways, okay? I'm going to take 100. I'm going to plug the 100 into this W variable right here. And it gives me 150. Okay? 150 meters. These are being expressed in meters. And what is 150? What is 150 times 100? 15,000 meters squared. That's the maximum area that we're going to get with these dimensions for length, right? This is the length. And the width right here. Okay. Right, length and width. Right? And again, just to show you the other way, to prove the point, I'll plug the 100 into the area formula. Negative 1.5 times 100 squared plus 300 times 100 is equal to 15,000 meters squared. So again, it's both ways. Okay, that's plugging the 100 that's right here into the area expression, and you get the same thing as if you multiplied 150 times 100. It's the same thing. So that's this problem. So here's the next problem. Very similar, it's just shaped a little bit differently. A barn which contains different livestock will use 240 meters of fencing to construct 3 equal rectangular regions. Therefore, there is no fencing along the side of the barn, so livestock can move in and out of the barn. Determine the maximum area of the pen. Okay, so again, we have a barn, right? We have widths and we have the length. We're not calculating the length because it's part of the barn. Okay, and obviously we don't need to build a fence barrier right here because the barn wall is right there. We only need it right here. Let's go ahead and do what we did last time. I'm going to go through it a little bit faster this time because I explained it once, and I just want to let you guys know how it's not too bad, right? Okay, so we have L